This is 4.4, applications of rational equations. Applications, of course, just means that we're talking about word problems for the most part. The good news is there's not really any new math, algebra technique that you need to learn. All we're doing this lesson is, interpreting the problem, and then we solve it using things that we already know how to do. So, number one, it says the sum of a number and 3 times its reciprocal is -4. So the sum of a number and 3 times its reciprocal is -4. So, the sum, that means we're adding stuff. The sum of a number, we'll just call it n or x or whatever you want to call it. The sum of a number and 3 times its reciprocal. Well, the reciprocal of n is 1 over n. And so 3 times its reciprocal would just be 3 times that. And so it says the sum of a number and 3 times its reciprocal is -4. And so if we can get that far, then we're just solving an equation. Now we do have to use our, rational equation solving techniques that we learned in the previous lesson to do it. But, most of these aren't too bad. So just to make this look a little nicer, 3 times 1 over n is actually 3 over n equals -4. And so if you'll recall from the last lesson, when we're solving rational equations, what we want to do is multiply every term by the same thing, and we want that thing that we multiply by to be something that'll make all the denominators cancel. Well, this one's easy because it only has one denominator, and that denominator is an n, so that least common multiple of the denominators would just be n. So, just like last time, we go in here and I multiply every single term by n. It's a perfectly legal move as long as we do it to every single term. It's a helpful move because now, well, that's just n squared. But here, these n's cancel, and I'm just left with that 3 that was sitting there. And then over here on the other side, I've got -4n. Well, now it's a quadratic. Now we need to make it equal 0. So I'm going to add the 4n over, get it in the right order. So now I got n squared plus 4n plus 3 equals 0. Well, this will factor pretty easily. N plus 3, n plus 1. And then, of course, my 2 answers here would be -3 and -1. Either one of those will work in this scenario. The scenario that says a number plus 3 times its reciprocal equals -4. If you just think about it, if you took -3 for instance, -3 plus 3 times -3's reciprocal, well, that would just be -3 minus 1, it's -4, so it works. -1, same thing. You can plug that back into that original equation, it's going to work. You don't have to worry about extraneous here, because the only thing that would make it extraneous would have been if we got 0 for an answer. And that's it. All right, number 2 is the same thing. It says the sum of a number and its reciprocal is -2. So this one's actually even easier. The sum of a number, so again, it's a sum, there's addition going on. The number and its reciprocal is -2. The sum of a number and its reciprocal is -2. And so now I'm just going to do the same thing that I did on that last one. I'm going to multiply everything by n. When I do that, that becomes n squared. That just becomes 1. That becomes -2n. Now I'm going to make this thing equal 0. This will factor to be n plus 1, n plus 1. And so my answer is just -1. I know on your printout, on your worksheet there, it says find the numbers or find the 2 numbers or something like that. It really shouldn't say that. It should just say find the numbers, because in the first one that we did, there were 2 answers. Here, there's only one. We didn't do anything wrong. There's really only one answer. It's just a sort of a poorly worded question. And that's it. All right, number 3, same thing. This time it says a number, the sum of a number, the sum of a number and 8 times its reciprocal is 6. So, number 3, the sum of a number and 8 times its reciprocal, remember that would just end up being 8 over n, is 6. And then it's just like the first 2. Multiply everything by n, that becomes n squared, that becomes 8, that becomes 6n. We're going to minus the 6n over to both sides like so. This thing will factor. This would be n minus 4, n minus 2. And then, of course, that means that your answers are 4 and 2. Either one of those numbers would satisfy that equation. Either one of those numbers would work in that scenario that they said in the problem. And that's it. All right, so this next part's where it gets a little hairier. It's the same thing, like the math part of it, the equation solving part of it is the exact same, but it's not as obvious how to set the equation up. Before we even get into it, I'm gonna talk for a minute. This isn't in your notes. As a matter of fact, in the guided notes that are there for you, there's a formula that, you know, for you to do this. And I know that a lot of you would probably just prefer me give you the formula, but I don't care what you prefer. I'm making the video, so I want you to see where it comes from. I want you to see why we do what we do. So this, like I said, this isn't in your notes, but just imagine for a second if you know, there was this job that I could do in 2 hours, and you and I are working together, let's say that, but it's a job that I could do by myself in 2 hours, and a job that you could do by yourself in, let's say, 3 hours. Probably makes sense because regardless of what it is, I imagine I'd be better at it than you. So I can do it in 2 hours by myself. You can do it in 3 hours by yourself, but we're gonna work together, and we wanna see how long it would take both of us together to do it. So obviously it's gonna be less than it would take either one of us to do it by ourselves. So it takes me 2 hours to do it by myself, takes you 3 hours to do it by yourself. If we work together, at the very least, we know it should be less than 2 hours. But let's think about it like this. If I can do the job in 2 hours, then that means that in 1 hour, I can do half the job. That makes sense, right? If I can do the whole thing in 2 hours, well then in 1 hour I can do half the job. In 1 hour, you could do a third of the job. Because remember, it takes you 3 hours. A third, a third, a third. So you're doing a third every hour. So we could figure out how much we could do in an hour together by just adding up those 2 parts. If I do half the job and you do a third of the job, by the way, that equals 5/6. That means that together we would do 5/6 of the job in an hour. So all we're trying to do is figure out how many hours will go by, you know, with us working together for the whole job to be complete. And remember, if a half means half the job, and a third means a third of the job, and 5/6 means 5/6 of the job, well then the whole job would be represented by 1. So what we're really trying to figure out is, well, how many times will 5/6 go into 1? How many times do we have to do that before we get to a whole job, to one whole job? And so this is some pretty easy division over here. 1 divided by 5/6 is just 6/5, which would be 1 1/5. So it'd be like 1.2 hours or whatever it was that we were measuring in, and that would be our answer. And again, that should kind of make sense. You know, if I can do half of it by myself in an hour, and you can do a third of it by yourself in an hour, then the fact that it takes us a little more than an hour to do it together should sort of make sense to you. All right, well, just keep all that in mind. Let me do some erasing. And we're gonna look at that first problem on your notes. So, that problem says, a bricklayer can build a wall of a certain size in 5 hours. Another bricklayer can do the same job in 4 hours. If the bricklayers work together, how long will it take to do the job? So, same idea. The one bricklayer, the first bricklayer, it takes him 5 hours to do it, so he can do a fifth of it in 1 hour. The other one can do it in 4 hours, which means that it would take him, he can do it in 4 hours, so he would do a fourth of it every hour. And you remember what we did a minute ago, where we took the sum of those and, we divided it into 1? Well, that's all I'm gonna do here. I'm gonna say 1 over t for total time, whatever. That's what it would be for both of them to do it together. And if you look on your notes, this exact, sort of equation in its general form is laid out for you. It says 1 over how long it takes the first guy to do it plus 1 over how long it takes the second guy to do it equals 1 over how long it would take both of them to do it together. And so now, this is just regular old rational equation solving, which we're experts at this point. I got a 5 and a 4 and a t. So I need a least common multiple there. I need a number that'll make all those denominators cancel. In this case, it would be 20t. And by the way, it doesn't have to be the least common multiple. If you pick out a bigger common multiple, this will still work. Like if you decided you wanted your common multiple to be 80t, well, it would still work. You'd still end up with the same answer. We just use 20t because it keeps the number smaller. It's the least common multiple. So I'm going to take that LCM and I'm going to stick it in every single numerator, just like we were doing in the last lesson and at the beginning of this lesson. And you're just going to start canceling stuff. And if you do it right, you're going to end up with an equation that doesn't have fractions anymore. That was the goal. So right here, I got 20 over 5. Well, 20 over 5 is 4. And then you got the t there. Plus, 20 over 4 is 5. And that also has a t. And then over here, the t's cancel. And so you just have 1 times 20, which is 20. 4t plus 5t is 9t. Divide both sides by 9. You get 20 over 9, which is 2 2/9. And 2 2/9 is about 2.22. I don't care how you write the answer. I just want to show you that, again, it kind of makes sense. One guy can do it in 5 hours. One guy can do it in 4 hours. If they work together, it'll take them 2.22 hours, so 2 and some change. That's it. That's the whole thing. All these are the same. There is one little curveball that we'll talk about in a second. So let's look at that next one. Next one says Kathy can paint a house in 6 hours. If Dan helps her, together they can paint the house, or paint the room, sorry, can't read. Paint the room in 4 hours. How long would it take Dan to paint the room by himself? So again, you got Kathy working, you got Dan working, and then you got whatever speed that would be total. So it says that Kathy can do it in 6 hours. This time they don't tell us how fast Dan can do it, but they do tell us that they can do it together in 4 hours. So the total is 4 hours. So that's 1 over 4. So Dan is the one that we don't know. So give him a 1 over x or 1 over t or whatever you're calling it. It doesn't matter. And now you're just doing the same exact thing. I've got a 6, an x, and a 4. The least common multiple there would be 12x. If you accidentally did 24x, it would still be okay. It would still work out. So I'm going to multiply all of these numerators by 12x. 12 over 6 is 2x. Here, the x's would just cancel. You'd be left with 12. And then over here, 12 over 4 is 3, so that would be 3x. Well, this one's pretty easy to solve. I'm just going to minus 2x over to this side. That'll give me x equals 12. That means that if Dan did it by himself, it would take him 12 hours. Kathy can do it in 6. Together they can do it in 4. Takes Dan 12 hours. That's it. All right, so this next one is the curveball I was talking about. But it's not a major curveball. It really kind of just, it makes perfect sense. It says a faucet can fill a bathtub in 15 minutes. A drain can empty the bathtub in 20 minutes. So this time they're actually, the two things aren't working together, they're working against each other. You got one thing filling the tub and you got another thing emptying the tub. So it should make sense to you that, you know, we can fill the tub, we can drain the tub. And when we fill the tub, it says that the faucet can fill the tub in 15 minutes. So every minute, it's doing a 15th of the job. It says the drain takes 20 minutes to empty the tub. So the drain is, you know, doing its thing, you know, 1/20th of its thing every minute. But, you know, they're not working together, so it wouldn't make any sense to add them. Like this water that's going in and this is water that's going out. So it would make sense to subtract that water that's leaving. So we got 1/15 minus 1 over 20. And then that t over there, or the x, or whatever you want to call it, that's going to be how long it would take the tub to fill all the way up. And before we even do anything, if the faucet can fill it in 15 minutes without any of it being drained, but while that's going on, we're draining some of it, well then it should make sense that our answer is going to be bigger than 15. I mean, the drain's slowing it down, slowing the process down. So we need an LCM here. We could do 60t. 60t. I'm going to multiply all three of these by 60t. So in my fill fraction over here, 60 over 15 is 4, so it's just 4t. 60 over 20 is 3, so that's 3t. And then over here, the t's would cancel, you would just be left with 60. And so this is super, super easy at this point. 4t minus 3t is t, and t is 60. So it's gonna take the tub, while this thing's filling it and this thing's draining it, it's gonna take it an hour to fill all the way up, 60 minutes. All right, last one. Light little wrinkle here, but not a big deal, and it's pretty easy. So it says Jamie, that's my name, Priya, and Paul can paint a room together in 2 hours. So all three of them together. You know, you got Jamie, Priya, Paul, and then you got the total. Well, all together, they will all work together, they can do it in 2 hours. So that means every hour, that would be a half. It then goes on to say that if Priya does the job alone, she can paint the room in 5 hours. So Priya gets a 1/5. If Paul works alone, he can do it in 6 hours. So Paul gets a 1/6. And then it says, if Jamie works alone, how long would it take her to paint the room? So Jamie's gonna be the 1/t. And, you know, these are all working together this time. It's not like the faucet and the drain. The only difference here is that we just had 3 things working together instead of 2, but nothing else really changes. I have a t, a 5, a 6, and a 2. I need a least common multiple. We could do 30t. $30t over t would just be 30. 30t over 5 would be 6t. 30t over 6 would be 5t. And 30t over 2 would be 15t. This is 11t. If I subtract it over to this side, that would be 4t. So 4t equals 30. And then we're just going to divide both sides by 4. T is 30 over 4, which is actually 15 over 2, which is actually 7.5. So it would take Jamie 7.5 hours to do it by herself. That's it. That's the whole lesson.